Hey guys, this video is to accompany the topic of finding the intervals of increasing and decreasing and the relative extrema by examining the first derivative. This is what we would call the algebraic way of doing it, where we're not given a graph. We're asked to find, again, either the intervals of increasing, decreasing, relative minimums, relative maximums. They're all going to be solved for the same way. I'm going to outline a process that's very similar to what was in the video. And you're going to continue to just use this process no matter whether it asks you to find intervals of increasing, whether it asks you to find intervals of decreasing, relative minima, relative maxima. All of that information is going to be contained in this one method of doing it. So let's go ahead and get started. First of all, I'm just going to outline the process and then we'll actually do it. So first thing that you're going to want to do on all of these is find the derivative f prime of x. After that, we're going to identify the critical numbers or critical points or critical values, depending on what you read. It's the critical points is what I like to call them. To find that, these are the places where f prime of x equals 0 or is undefined. For all of the DeltaMath problems, it's just going to satisfy this first one where f prime of x equals 0. None of these have undefined points. There was a couple on the Edpuzzle video that did have undefined points, but in general, it's going to be where the function equals to 0. If it is something like a rational function, then it will have places where it's undefined as well. But we're going to look at strictly at polynomials for this particular assignment. Okay, so identify the critical points. After we've done that, we are going to set up a sign chart. One sec here. So we set up a sign chart to identify intervals of increasing/decreasing. Then after we've done that, based on if a function changes from increasing to decreasing or decreasing to increasing, then we're going to identify the relative minimums and maximums. So identify relative mins and maxes. And how we're going to find those is relative mins occur where the function changes from negative to positive or increasing to decreasing. And a relative max occurs where the function changes from positive or increasing to negative or decreasing. So that's the general structure that we're going to do for all of these. So with that, let's go ahead and do our first one. So our first function there, we're just going to go ahead and do it on this other page. F of x is 3x to the third plus 4 to 5x squared plus 81x plus 40. And like I said, all of these on DeltaMath are going to be polynomials. So they all work out rather nicely. You're going to be able to factor all these and you don't have to worry about places where it's undefined. So our first step is always to find the derivative. It's going to be 9x squared plus 90x plus 81. The second step is to then set the derivative equal to 0. So 9x squared plus 90x plus 81. And we're going to find the critical points. To do this, we need to factor it. Since all of these have a factor of 9, I'm just going to go ahead and pull a 9 out. Or this is x squared plus 10x plus 9 equals 0. And then factoring that would become 9 times x plus 1 times x plus 9. Set each of these equal to 0. The 9 can just divide out. So x plus 1 equals 0, and x plus 9 equals 0. So x equals -1, and x equals -9. These are our critical points. These are the only two places, where a min or max can occur. They're also the only two places where a function can change from positive to negative or negative to positive, meaning increasing to decreasing or decreasing to increasing. So the only two possible places this function can change. So our next step then is going to make what we call a sign chart. With this, I would recommend sticking with this general table here for all of the questions. Again, even though it might only ask you one aspect, it's a good idea to get in the habit of drawing this whole table. It kind of makes you have a clear picture of what's going on here. So the first thing is going to be our intervals. Our intervals are always going to start with -infinity, and they're going to go up to our first critical number, meaning sort of our lowest critical number. If we're to look from -infinity to +infinity, the first place would be here at -9. So we're going to -infinity to -9, parentheses on both because we're not including -9. Then we're going to start with -9 up to our next critical number, which is -1. Then it's going to be -1. If we had another critical number, we'd then list that. If it was like 5, there isn't, so it's just going to go all the way up to +infinity. So our function is going to have the same behavior, whether it be increasing or decreasing, on these entire intervals. So on the first interval, it's either going to be increasing or decreasing the entire way. Second interval, it's either going to be increasing or decreasing the entire way. Same with the third one. So our next step is to figure out by plugging in test points. So I'm going to say f prime of b. And we're just going to plug a number inside of the interval into our derivative and see if it gives us a positive or a negative. So for this first one, we could do like f prime of -10. And all we really care about is if it's a positive or a negative. So what I would advise you do is just type the derivative into your y equals. So just in the y1, I'm going to type in, make sure you're typing in the derivative, not the actual function, 9x squared plus 90x plus 81. And our table, so if we plug in -10, we get positive 81, so I'm just going to write a plus sign. If I plug in, say, -3 for the other one, f prime of -3, because that's in the interval, we would get a -108, so I'm just going to write a negative, meaning that whole interval, we would get a negative no matter what number we plugged in. And I'm going to plug in f prime of +1 for the last one, just type it into my table, and that's positive 180, so I'm going to write positive. So here, the next column, I'm going to write increasing / decreasing. So if something has a positive sign when we plug it into the derivative, that means it's increasing. If something has a negative sign, which this next one does, when you plug it into the derivative, that means it's decreasing. And we've got another positive, so that means it's increasing. So if we were asked a question like, well, what are the intervals of increasing? We would say -infinity to -9, union -1 to +infinity. Or if we were asked decreasing, we would say -9 to -1. So the last thing that we're going to need to figure out is the mins or the maxes. To figure that out, we're going to be looking at these sign changes here. So if something changes from increasing to decreasing, you can even like draw a little picture if you have trouble remembering. But if your function's going up and then it starts to go down, well, that's going to be a maximum, right? It's a little hill. And then if something's going down and then it starts to go up, that's going to be a minimum. So now we can identify mins and maxes. So we got a relative max here, and that's at, we're looking for the x coordinate, which is right here, -9. That's where it changes at -9. I believe DeltaMath just asked for the x coordinate. Yeah, it just asks for the x coordinate. Typically what you would do is you would want to find the y coordinate as well. So to find that y coordinate, what you would do is you would plug it into the original function. So you would do f of negative 9. Because, again, you wouldn't plug it into the derivative at this point because the derivative tells you about the slope, but the original function would tell you the y value. So you would plug that into the original function, and that would give you the y value. We're only asked for the x value, so we're just going to type in negative 9. We could also say that, again, there is a relative min, depending on what the question asks, at negative 1, because that's the x value where it changes, and then comma f of negative 1. So you would just figure out what that y value is if you ask for that. So that is all the information that you'll need for any of these questions. Just solve them all the same way. Again, you do get some extra information, but this is the process that you would want to use for any AP question that were similar to this. Some of them you'll even be asked to make these sign charts as proof. And then eventually we'll add another thing to this, which is concavity by looking at the second derivative. So we'll add to this chart in a little bit. Let's go ahead and answer the question. So we were just asked for relative minima. Actually, sorry, I thought it was max. Relative minima, which is going to be negative 1, right? It's our only relative minimum. So we're going to type that in. And again, it's just the x coordinate, so we'll just type in negative 1. And there we go. So as it says, critical points, set the derivative equal to 0. Undefined what happened. Solve it, we get negative 9 and negative 1. They do a little bit less intense sign chart here. They just do this one. But again, I would advise making the table because then it's a lot more clear where these occur. And this is what the graph looks like. So you can see we're increasing because the derivative is positive. At negative 9, it switches to a negative derivative, which implies the function is decreasing. And then at positive 1, the function starts increasing again, which is a positive derivative. Right. So let's go ahead and do another one or two of these. Let's see if we can get, let's go ahead and do this relative maxima. All right, so the next one here, let's do it on this slide. Our first step is to find the derivative, f prime of x. So that's going to be negative 2x to the fourth plus 20x to the third minus 48x squared. We're going to set that equal to 0 for our second step. Solve for the critical numbers. And we're going to need to factor this. All of them should be factorable. So looking for your greatest common factor, there definitely is a negative 2 in everything, and they'll have an x squared. So I'm going to pull that out, negative 2x squared, and then we'd be left with x squared minus 10x plus 24. Set this equal to 0. Then factoring negative 2x squared, it would be, let's see, same sign. Looks like x minus 6 and x minus 4. Because they have to have the same sign to give you a positive, and they have to add to give you negative 10 equals 0. And then so solving for each of these, negative 2x squared equals 0, we get x equals 0. X minus 6 equal to 0, we get x equals 6. And x minus 4 equal to 0, we get x equals 4. So these are critical values, or critical numbers. And now we can set up our table. So for our table, it's going to be a little bit larger. Might actually need to erase this for a sec. All right, so I'm going to go ahead and erase this. Hopefully you got it written down. Third step, make our sign chart or our sign table. So we've got our interval. Now we've got another interval in this one because we got 3 critical values. Our first one is going to be from negative infinity up to 0 because 0 is the first number that would occur on the number line. The next one would be from 0 to 4. The next one would be from 4 to 6. And then from 6 to positive infinity. Next column, we're going to plug in a value on that interval into our derivative. So f prime of b. For our first one, we could plug in like -1 would be fine. F prime of -1. And again, what I would do at this point is pull out your calculator, plug it into y1. That's what I'm going to do. Don't try to do all these by hand. Rely on your calculator when you can. So in my table, plug in -1. I get -70, so that's going to be a minus. Next one, I could plug in +1. Still get a minus. I get a -30. Next one, I'm going to plug in, let's say 5. Make sure you're writing this out too. Sorry. This is supposed to be a negative. Writing these out because on the AP test, you will need evidence to show what you're plugging in. The next one, you do get a positive. It's a +5. Or, sorry, +50. Next one, f prime of, let's say, 7. And we get a negative, -294. So there's our signs. So the next thing we can do is identify intervals of increasing and decreasing. So increasing, decreasing. Here we've got a negative, so that means it's decreasing. Another negative, so it's still decreasing. We've got a positive, so that means it switches to increasing. A negative switches to decreasing. So at this point here, the first critical value, it doesn't change signs, so it's going down, and then it sort of levels out for a second. Derivative is 0, and then it keeps going down again. But there's not a min or max there. So you can kind of envision a function sort of like the shape, it goes down, and then it sort of levels out, and then it keeps going down. That's kind of what we have going on. So there's neither a min or max at that point. However, there is a couple places we're going to identify mins or maxes here. Here we've got a decreasing to an increasing. So that would look like this. So that's going to be a min, relative min, at the point 4, and then f of 4. So whatever that would be. And then here we've got an increasing to a decreasing. So that tells us it's a relative max at the point 6, f of 6. We're asked to find the max on this one. So we would want to just type in the x-coordinate of the max, which would be 6. But again, we've got all the information we would really need to know about this function that we can find by looking at the first derivative, all the intervals of increasing, decreasing, all of the mins and maxes. Let's go ahead and submit that. And we'll do one more together. Let's see. I thought there were some of these there. There we go. Intervals of increasing. So let's do one of those. So first step is first derivative, f prime of x, -12x squared plus 4x. So that equal to 0. This one's a little bit easier. Our greatest common factor here, I'm going to pull out a -4x. So we're left with a 3x minus 1 equals 0. So then our two critical values would be x equals 0 and x equals positive 1/3 when we solve those. We then can go ahead and do our intervals. These are going to be less intervals because we've got less critical values. Our first one is -infinity up to 0 because that's our first critical value. We've then got 0 to 1/3, and then we've got 1/3 to infinity. So some of these can be not that difficult, right? Pretty simple here. We're then going to plug in a test value, so f prime of b, with like f prime of -1. Again, plug the derivative into your y1 on your calculator. Even if you think you can do it in your head, it's not a bad idea to just plug it in. If you can, use your calculator. So plug in -1, I get -16, so that's going to be a minus. And then f prime of, we got to choose a number between 0 and 1/3. So I'm going to go with like 1/4. It's a little bit less than 1/3. That is a positive 1/4. And then any number bigger than 1/3, so let's just say 1. And that gives us a -8. So then we can go ahead and identify increasing, decreasing. It is decreasing to start, switches to increasing, and then decreasing again. We're asked to find intervals of increasing, so it's just going to be this one interval. If you had 2, then make sure you use the union symbol, but this we only have the 1. We could also identify mins and maxes if we were asked that. We would have a decreasing, increasing, so there would be a max here at 0, f of 0, and then here increasing to decreasing. I'm sorry, decreasing, increasing would be a min, not to confuse there. And then increasing, decreasing would be a max at 1/3, comma f of 1/3. Increasing and decreasing. I always draw the little hills. So it's easy to get them mixed up with all this going on. Draw the little hills and valleys. All right, so if we were asked that, we could then answer that. We are just asked for intervals of increasing. So that's just going to be 0, comma 1/3. And that is it. All right, so take your time on those. Do your best. If you're getting to the point where you've done a ton of them, I know they take a little time, and you can't quite get all of them. Just put a comment on there that you spent 2 hours on it. You couldn't quite get all of them, but you need to at least get several of these. I can also see how much time you're spending on each question. So do your best on this and reach out to me if you need help.